So in last lecture, we have seen the attenuation, dispersion, intermodal dispersion, intramodal dispersion, and what is the cause behind the dispersion. Now in this video, we will discuss intramodal dispersion in detail. So through the optical fiber signal, suppose this is the optical fiber, this is your optical fiber. You are giving input signal. So input signal is transmitted via this optical fiber. So for this optical fiber, this is input, and from another end, we are getting the output. So when we observe this output signal, then we see this output signal is the delayed version of the input signal. So basically this delay is inversely proportional to the group velocity of the wave. In last video I have discussed about the group velocity. Please refer that to understand how this signal delay is because of this group velocity. So now there is a one more parameter, propagation constant, and this propagation constant is frequency dependent over a bandwidth of delta omega, and the corner and the center frequency is WC. So we have one propagation constant resulting in a specific delay time. So what we have observed? We observed that the output is delayed, and the reason behind that delay or the delay is because of group velocity and group delay. So basically this delay between input and output signal can be delay between input and output signal. If we identify what is the reason behind this delay, then we can say the group velocity is responsible for the group delay. So basically the output signal is represented by this group velocity and group delay. So that's why this type of dispersion is known as GVD. What do you mean by GVD? GVD means group velocity dispersion. Here you can see group velocity dispersion or intramodal dispersion. So this GVD phenomena arises due to finite bandwidth of the optical source, and it depends on the refractive index, and which is dependent on the wavelength and the group velocity. So optical pulse propagation, if we are transmitting optical signal via optical fiber, then because of this intramodal dispersion or GVD, there is a pulse broadening. And because of this, ISI, inter-symbol interference, arises. So in next slide, we will see what is the ISI. The reason behind this inter-symbol interference is GVD, that is group velocity dispersion. This is the another name of intramodal dispersion. So now what is ISI? Here in this diagram, you can see there are two axes. This is showing the the y-axis is showing the pulse shape and the amplitude, and this is showing the distance along the optical fiber length. So in first case, these are the input pulses. So there are two input pulses. Here you can see two input pulses, and there is a clear-cut difference between these two pulses. So here you can see separate pulses at any particular time, T1. In next diagram, you can see there are distinguishable pulses at time T2, and in third case, here you can see these two input pulses get broadened, and it is little difficult to distinguish these two pulses. So here, due to broadening of the pulses, inter-symbol interference occur. And as they move along if we observe at time t4, then here we can see these two input pulses are hardly recognized as different pulses, or we can say in this case input pulses are indistinguishable. So because of dispersion there will be inter symbol interference, and this is caused because of the broadening of the input pulses. So now next, how you will measure the information capacity of optical fiber. So the information capacity is specified by the bandwidth distance product, that is bandwidth into L, and its unit is gigahertz per kilometer. And for the multi-mode step, if we see the range of this bandwidth distance product, then for multi-mode step index fiber, this is about 20 megahertz per kilometer. For graded index, this is about 2.5 gigahertz per kilometer, and for single mode fiber, this is only 10 gigahertz per kilometer. So this is about the ISI and the information capacity of the optical fiber. Now next, what is the reason till now you have seen the reason behind this GVD or intramodal dispersion. Now how you will calculate this? So this can be calculated as the group delay per unit length. This is the group delay, and this is the unit, this is the length of the fiber. This is the group delay. So this is measured by the tau g by L. This is given by this d beta by d omega. Omega is the angular frequency and beta is the propagation constant. So by solving this, you can measure the dispersion. So here, this parameter is known as, if we solve these equations, so we will get the value of D. So here D is in PS by N given by this. So we will discuss this derivation in next video, and this is very important, and we will also solve the numerical on the basis of dispersion and how the GVD parameter is calculated and what are the different parameters on which this group delay depend. So we will discuss all these in the next video.